All right, so today we're going to start off with math properties of multiplication. All right, so there are 5 different properties that we're going to learn. Today we're focusing on just 3: commutative property, identity property, associative property. And then tomorrow we would review all 3 and learn about the distributive property and the zero property. So we're going to focus today on math properties. What is a property? A property is a rule that works for all numbers. Please make sure you're taking notes. All right, a property is a rule that works for all numbers. So the first one we're going to look at today is the commutative property. What is the base word of commutative? So that means it's commute. And what does commute mean? So in order to give us a hint, my parents commute to work by train. Commute means to travel regularly over some distance. So when we're commuting, commuters usually follow the same path into the city and from the city. So when you're commuting, you're going the same, all right? So commute is the same regardless in the direction you're going. So from the house by train to the city, all right? Or from city to and back again. So do we remember the property, the commutative property for addition? It states that the order of the addends, here are the addends over here. It doesn't change. I mean, no matter the order, it would not change the sum, okay? So the order of the addends doesn't matter. The resulting sum, the total, would always remain the same. So here we've got 5 plus 4 is 9, or 4 plus 5 is 9. It doesn't matter the order in which these are, almost like what we do in our number talks. The same, our sum will end up being the same. All right, so this property or rule is similar to the commutative property for multiplication. All right, so 5 times 4 is 20. What if we change the order of the factors? So this is a factor, and here's another factor. All right, so these are factors. Even if we change the order, it's still going to be 20. 4 times 5 will still give us 20. Remember, we're still working on the commutative property. So the order of the factors don't matter. The resulting product will remain the same. 5 times 4 is 20. 4 times 5 is 20. You can change the order of the numbers you multiply, and the products will not change. All right, so now we're going to look at some sample examples. Here's the question. Show the commutative property of multiplication using 2 and 8 as factors. 2 times 8 is 16. 8 times 2 is 16. So no matter how we change the order, it does not change the product. All right. So even if we change the order of the factors, the product does not change. Here's another example. Show the commutative property of multiplication using 9 and 3 as factors. 9 times 3 is 27. We switch it around, switch the factors around. 3 times 9 is 27. Here's another one showing the commutative property of multiplication using 4 and 2 as factors. 4 times 2 is 8, and 2 times 4 is 8 as well. So here we're going to go ahead and fill in the blank. So the equal sign means same. 3 times 4 equals 4 times, and if you said 3, you are correct. 4 times 3. All right, because both would give us 12. And how can we prove it? We're proving this equation by writing out the commutative property and showing the commutative property. 3 times 4 is 12, and 4 times 3 is 12. Here we're going to fill in the blank. 6 times 7 equals 7 times 6. It's going to give you the same number. It's going to give you the same number. And in order to prove this, when we do our multiplication, 6 times 7 is 42, and 7 times 6 is 42 as well. In order for us to fill in this number, 9 times 5 equals 5 times 9. If you said 5, you are correct. And to prove this, 9 times 5 is 45, and 5 times 9 is 45 as well. All right, so these are examples showing us and explaining the commutative property of multiplication. Now we're going to go ahead and look at the identity property of addition. First of all, we've got to talk about what does identity mean. All right, so to help us, we're going to look at the word in a sentence. The identity revealed, or the handwriting revealed, the identity of the person who wrote it, who wrote the note. Identity refers to the state of being the same as one described. All right. So when you think of identity, think of a mirror. So when you look at yourself in a mirror, who do you see? The same you. When you look at the mirror, your reflection looks the same as you. So in addition, when we're doing this in addition, if our number is 5, what number do we have to add to 5 so it still stays at 5? That would be 0. All right. So this would be for addition. Now for multiplication, it kind of works in a similar way. What number do we have to multiply by the number we're talking about to give us the same number so that the identity stays the same? And that would be 1. All right. So what number can be multiplied with the first factor to make the product the same? 1. 5 times 1 is 5. So remember, we're working on the identity property. And identity, I'm thinking of like a mirror and a reflection, so that the reflection of the factor is the same as the product. When you multiply 1 with any number, the product of that number will remain the same. All right, so it keeps its identity. It stays the same. Now let's look at some examples. So we're showing the identity property of multiplication using the number 2. 2 times 1 is 2. Here's another example. Show the identity property of multiplication using the number 10. 10 times 1 is 10. Remember, with identity, we want to keep the factor the same as the product. How about if we change our number to 150? Show the identity property of multiplication using the number 150. And if you said 150 times 1 equals 150, you are correct. So we've gone over commutative property, where the factors don't change. The order of the factors do not change the product. You still end up with the same product. Identity property, where the identity of the factor still stays the same as the product when we multiply by 1. And now we're going to work on associative property of multiplication. So here with the associative property, what is the base word for associative? So associate, what does that even mean? I'll give you a hint by looking at this sentence, by using it in context. Amber began to associate with Shelby when they were in the same 2nd grade class. Does that ring a bell? Associate means to join together, as in friendship. Most people associate with multiple friends. All right, so here's our friend here. We've got Josh is often with Hannah, a classmate during school, but then he associates with his neighbor, Kevin, when he's at home. All right. Here is the associative property for addition. It states that when you group numbers, to add how you group them does not change. All right. So when you group numbers to add, however you group them it does not change. Here we've got 2 plus, and then we've got parentheses 3 and 5 equals 10. We always work with the parentheses first. So 3 plus 5 will be 8, plus 2 is 10. And then here in parentheses, we've got 2 plus 5, 2 plus 3, 2 plus 3 is 5, plus 5 is 10. So especially when we're doing our number talks, a lot of us in class have been using the associative properties of addition. It is similar for the associative property of multiplication. All right, that the order in which we add the factors does not change the product. So always remember that we always start off with, we need to perform the operation and start off with the parenthesis first. Here is our parenthesis. So here we've got 3 times 5 is 15, times 2 will give me 30. All right, so we've got 15, and that will give me 30. For the next one, we're also starting with a parenthesis first. 3 times 2 times 3 is 6, times 5 will give you 30. So the way that these factors are grouped, it doesn't matter. Why? Because the product will always end up the same. This is an associative property of multiplication. When you group factors to multiply, how you group them does not change the product. All right. So here is an example. Show the associative property of multiplication using the factors 2, 1, and 8. Remember how you group them doesn't matter. The product will always remain the same. So here we've got 1 times 8 is 8, times 2 is 16. Here 2 times 1 is 2, times 8, 16. And in another example, show the associative property of multiplication using 4, 2, and 5. Remember how we group them does not matter. The product will always remain the same. So we've got here, starting with a parenthesis first, 2 times 5 is 10, times 4 is 40. Remember, and you're going to notice this 2 is associating with 5 right now. And watch 2 now associating with 4. So 4 times 2 is 8, times 5 is 40. Here's another example. Show the associative property of multiplication using 8, 4, and 2 as factors. 4 times 2 is 6, is 8, times 8 is 64. Remember, the 4 is going to associate with 8 now. 8 times 4 is 32, times 2 is 64. All right, so with the associative property, the way that it is grouped does not affect the product, okay? Now, determine the answer of this factors. 5 times 8 is 40, times 2, 80. Now we're going to rewrite this equation using the associative property. So rewrite it. Now 5 is being grouped with, or is associating with 2. 2 times 5 is 10, times 8, 80. To determine this answer, 3 times 2, we're starting off with a parenthesis first, remember, is 6. 6 times 3 is 18. Now we're going to rewrite this equation using the associative property, and that would be 3 times 3 is 9, times 2 is 18. Here's another example. 5 times 10, remember, because I'm starting off with a parenthesis first, is 50. And 50 times 4 is 200. Now I'm going to rewrite this equation using the associative property, and that would give me 4 times 5 is 20 times 10 is 200. All right. And so we went over the commutative property, the identity property, as well as the associative property of multiplication.